So the title of our project is Tidy Up Robot. My name is Jürgen Sturm, and I come from the University of Freiburg. This is a joint initiative from 3 robotics groups there, from Wolfram Burgert's lab, Bernhard Nebel's lab, and Martin Riedmüller's lab. And we are all from the Department of Computer Science from the University of Freiburg. And one question that I was asked several times in the past few days is actually, where is Freiburg? And well, Freiburg is in the southwest of Germany. Freiburg is a relatively small city with 200,000 inhabitants, and our university has more than 30,000 students, so nearly or more than 1/3 of all the population of Freiburg actually is somehow studying at the university. It's a traditional university that has a large technical faculty. We have computer science and microsystem technology there, and we are very strong in artificial intelligence and in robotics. There are actually 5 robotics groups in Freiburg, but only 3 of them participated here now in the proposal. That's the Autonomous Intelligent Systems Lab of Wolfram Burgert, the research group on foundations of artificial intelligence, headed by Bernhard Nebel, and the machine learning lab headed by Martin Riedmüller. And we also have 2 other robotic groups, the humanoid robots group from Maren Benewitz and the social robotics lab from Kai Arras. The Autonomous Intelligent Systems Lab, mainly where I'm also a member of, is mainly concerned with mobile robots. And we had in the past very strong contributions to, for example, mapping with mobile robots. Most of you, I guess, will know the G-mapping package from Giorgio Grissetti. We also did lots of stuff with navigation and localization of mobile robots. And all of that is in the theme of probabilistic robotics, that is bringing probability theory and robotic state estimation together. In the images, you can see some of the robots that we have in our lab. You see a large variety of completely different platforms. We have several mobile platforms that we use indoor and outdoor. We have also flying vehicles like the blimp on the top of the picture, or the quadrotor on the lower left. And then there is the research group on the foundations of artificial intelligence, headed by Bernhard Nebel. The group is very strong in action planning. They do obviously more things than that, but that's one of their main research interests. They have contributed very many things in theory, and also showed in practical experiments that it is useful. They organize on a yearly basis planning competitions, international planning competitions. And they did also lots of stuff in the realm of qualitative temporal spatial reasoning. There are also several RoboCup teams in this group. They won the World Championship 3 times in the past, and they also built the world's first autonomous table soccer robot, which is pretty hard to beat, or basically impossible to beat at human speed. And they participate at the RoboCup Rescue League. And the third group is the machine learning lab from Martin Riedmüller. They are very strong in everything which is related to machine learning tasks. So they did a lot in reinforcement learning using neural networks. And the main focus for them is to make it really learn fast, so learning from only few training samples, because a robot only has a finite number of finite time to actually collect data. So you wanted to really learn efficiently policies and strategies. So they have shown the efficiency of their systems in several applications. For example, a forecasting system for the distribution of newspapers in Germany. But also, they've also won the World Championship in RoboCup before Martin Riedmüller came to Freiburg 1 year ago, and also in industry projects. Now I come to the real project that we want to do with the PR2. Well, the project goal of our Tidy Up robot is that we want to implement a reliable fetch and carry application for mobile manipulators. And we specifically want to focus on domestic environments. So just to give an example, consider the case that you have the robot in your home and you want it to tidy up the living room. So the robot needs to go to the living room, maybe open the door to get in there, then look at the table, see all the objects, and then move all the objects to where they belong. That means bringing them back to the kitchen, putting them in the dishwasher, putting them in a cupboard, and so on. And for that, we have, from technical side of view, we want to contribute five different software modules that we license under the LGPL license. So on the top left, you see the feature-based object recognition. I will go on over all of these modules in more detail on the later slides. We provide a module for learning kinematic models for articulated objects. And then maybe the most central module that we want to provide is a generalized map representation that allows us to store all the information that we get from the various modules in a single place that's able to provide symbolic information and semantic information over the world, such that we not only have the map of the environment, but also have the, all the objects located in the environment and all the properties of these objects also stored in this semantic map. And we need that for a symbolic planner that then comes up with a plan that we can actually execute on the robot. And finally, we have a reinforcement learning module, or we want to implement a reinforcement learning module that then controls the motion of the manipulator.